This is a vector. The main feature of a vector is that it has magnitude and direction. Now, if this was in text, it would be a bold A. But because I'm using my handwriting, I can't do a bold A, so we underline it to show that it's a vector. It can also be written as AB, and we put an arrow to show the direction of the vector from A to B. It can also be written as a column vector. The column vector for this one is 3, 4, written like this, 3, 4. These numbers are positive because I went to the right and up. If I go to the left, the top number needs to be negative. If I go down, the bottom number needs to be negative. The magnitude of this vector is the length of it, and to work this out, I'm going to use Pythagoras' theorem. I can draw a right-angled triangle here. This length is 3 and this is 4. So I now know that the length is the square root of 3 squared plus 4 squared. This is the square root of 9 plus 16, which is the square root of 25, so the magnitude is 5. Here are some questions for you to try. Press pause and write these vectors as column vectors. When you're ready for the answers, press play again. Here are the answers. Notice the use of negatives on these. This is the square root of 9 plus 16, which is the square root of 25, so the magnitude is 5. Here are some questions for you to try. Press pause and write these vectors as column vectors.
Tell me when you are ready to give the answers. Ready again? Let me know. I'm just running through this video so that when we start the questions, everybody has a basic concept. Are we ready now? Let me know so that I can continue. All right, let's continue.
When you're ready for the answers, press play again. Here are the answers. Notice the use of negatives on these two. We can also see, looking at the diagram, that vector A and vector C are the same, and we can see this in our column vectors as well. They're both 3, 2. I can add vectors in two ways, using the diagram or using column vectors. If I work out my column vectors for these two, this one is 3, 2. This one is -2, 2. When I add two vectors together graphically, I draw them nose to tail like this. We can see that going from here to here and then to here is the same as going from here to here. This is called the resultant vector. I've drawn it in a different colour, but on an exam paper it would be shown with a double arrow. If I use the column vectors, I have 3, 2 plus -2, 2. Adding these two, 3 plus -2 gives me 1, and adding these two, 2 plus 2 gives me 4. So my resultant vector is 1, 4, and we can see that this is the same as the resultant vector on the diagram, 1, 4. Vectors can also be multiplied by a scalar. A scalar is a number. Graphically, I can see that if I multiply the vector a by 2, I get 2a. The vector a was 3, 2, and the vector 2a I can see is 6, 4. If I use the column vectors, I have the vector a, 3, 2, being multiplied by 2 to give me 6, 4. If we multiply by a negative scalar, we can see that it reverses the direction as well. This is a typical exam question. To answer this question, I need to work out what vector A plus vector B is as a column vector. Vector A is 2, 3, and vector B is -1, 2. So my column vector is 2 plus -1, which is 1, and 3 plus 2, which is 5. For the second part, I need to start by multiplying vector A by 2. This gives me 4, 6. I then need to multiply vector B by 3, which gives me -3, 6. 4 minus -3 gives me 7, and 6 minus 6 gives me 0. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play.
All right, please try those for me. And see if you'll get the same answer as what is going to be given. I guess you should be ready by now, right? Everybody should have completed those two questions. Everybody still waiting? Still working, that is, and everybody? Are you still working? All right, look at the answers now.
Here are the answers. Four minus 3 gives me 7, and 6 minus 6 gives me 0. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. In this more difficult exam question, I'm given a diagram which I'm told is a trapezium. I'm also told that DC here is parallel to AB here. This, I'm told, is vector x, and this is vector y. And I'm also told that AB at the top is 2DC. So I know that AB is 2 of vector y. I'm also told that N here is the point on this line which is split into the ratio 3, 1. I need to express vector NC in terms of vector x and vector y. I'm going to start by drawing on vector NC. I now need to find a route from N to C going along paths that I know. I know these two, and I also know this bit here, because I know that AB altogether is 2 of vector y. I know that this has been split into the ratio 3, 1. So 2 of these is 1 of vector y, making that half of vector y, that half of vector y, and that half of vector y. I can now work out what NC is. It's minus 1.5 vector y minus vector x plus vector y. I can now simplify this to get minus 1/2 vector y minus vector x. So vector NC equals minus 1/2 of vector y minus vector x. Here's a question for you to try. Press pause and have a go at it. When you're ready for the answers, press play.
Again, any question? Or it is as clear as crystal? Can you explain again, please? All right, let's go over it.
I know these two, and I also know this bit here, because I know that AB altogether is 2 of vector y. I know that this has been split into the ratio 3, 1. So 2 of these is 1 of vector y, making that half of vector y, that half of vector y, and that half of vector y. I can now work out what NC is. It's minus 1.5 vector y minus vector x plus vector y. I can now simplify this to get minus 1/2 vector y minus vector x. So vector NC equals minus a half of vector y minus vector x. Here's a question for you to try. Press pause and have a go at it. When you're ready for the answers, press play.
Whenever you see this, this is telling you that the particular line is cut into three parts. Two parts go to BT and one part goes to TC. All right, just bear that in mind. All right, so we have AC being equals to X and AB equals to Y. So you're asked now to write down in terms of X and Y the expression for BC. Vector BC, so vector BC is moving from B to A, and then from A to C. B to A, and then from A to C. Look at the arrow. The arrow will tell you whether the arrow tells you the direction of the vector. So because we're moving from B to A, which means we're going in the opposite direction of the arrow, this would have been negative Y. So whenever we are moving in the opposite direction of the arrow, the sign of the vector changes. Now in this case, you're moving in the same direction of the arrow, so the sign remains the same. So you'd have negative Y plus X, which is the same as X minus Y. And I prefer write it like that, X minus Y. Everybody understands that? Any question? Okay. So now we're going to talk about AT. And AT would be here. That's AT. Now AT is moving. So AT is moving from A to C, and then from C to T. All right. Any question? Okay, so this now is C is, so what is CT equals to? CT equals CT CT is 1/3 of CB. So what is CB equals to? CB is from this plus that, so it's y minus x. So that's equals to x plus 1/3 of y minus x. One third of y minus x. Remember that BC is in this direction, x minus y. So CB would be the opposite of that. And so this is going to give me x plus 1/3 y minus 1/3 x, and that is going to be equals to 2/3 x plus 1/3 y. And your students of higher learning, so this is going to be 1/3 into 2x plus y. And as you go along, you will know why I went there. This is not a must for a question like this. So you don't have to do this. Right? You don't have to do that. But for like question that requires you to do collinearity and prove parallelness and collinearity, it's best to practice to do it this way. All right, any question? Any question?
Here are the answers. A nicer way of writing this one would be vector x minus vector y. I'm going to show you how I got this answer. I'm looking for the vector at. If I look at my diagram, I can see that to get from A to T, I can go from A to B and then from B to T. This will give me the resultant vector at. So I now have that vector at equals vector AB plus vector bt. To find vector bt, I'm going to use this information here. This is telling me that the side BC is split in the ratio 2 to 1. So BT is twice as long as TC. This tells me that this length here is 2/3 of the total length. So I now have that vector AT is vector AB plus 2/3 of vector BC. Vector AB is vector Y. Vector BC is here. It's vector X minus vector Y. So I have 2/3 of vector X minus vector Y. I can now simplify this. I have vector Y minus 2/3 of vector Y, which gives me 1/3 of vector Y, plus 2/3 of vector X. Now, although this answer is written in a different order to this answer, we can see that it's the same, 1/3 of vector Y and 2/3 of vector X. Another way to get this answer would have been to go from A to C and then from C to T. You may have done this, but you should have the same answer. Here's a question where you're going to do part 1 and then I'm going to do part 2. Press pause and have a go at part 1 only. When you're ready for the answer, press play.
All right, so everybody understands the first the question that was just finished. Any question on that part as we move to this part? All right. See, Caris is saying no. Anybody else? All right, so let's look at this now. AN, based on the question, it tells us that ABC is a triangle. M is the midpoint of AC. Midpoint means that it is in the position that is a half of AC. So AM is a half of AC and MC is a half of AC. And that N is a midpoint, is the midpoint of BC, same principle applied. So you want to find what is AN, to write AN in terms of X and Y. Can anybody tell me what that should be? Can you tell me what that should be? AN, I'm taking it from there. So AN is equals to AC plus half AC plus half of BC, CB plus half of CB. But we don't know what is CB, right? Do we know what is CB? CB, so we have to calculate what is CB. So go ahead and calculate what is CB for me. CB would equal to what? CA plus AB. Let's put in our arrows. This is AC. This is AB. This is AB. So BC, so CB, CB, C to A, and then to B. This would be negative X, negative Y plus X, which is the same as X minus Y. And as I said, I love to work with the negative sign in the middle. So this is going to be equals to AC is Y plus a half of X minus Y. Half of X minus Y. And this, work that down for me. Work that down and tell me what you get. That's what you get, half X plus half Y. Half X plus half Y. Getting 1.5 Y plus X. Let's see. I could be incorrect. So let's see if I am correct and or Shanice is correct.
I'm asked to find vector AN. If I look at the diagram, I can see that to get from A to N, I can go from A to B and then from B to N. So I have that vector AN is vector AB. I also know that N is the midpoint of CB. So the vector BN must be half of the vector BC. This gives me vector AN equals vector AB plus half of vector BC. I know that vector AB is vector X. So vector AB, vector X. I need to find vector BC. To get from B to C, I'm going to go from B to A and then from A to C. I know that vector AC is Y. I can now see that vector BC is minus vector X plus vector Y. So I now have a half of minus vector X plus vector Y. If I simplify this, I get vector X minus a half of vector X, which is a half of vector X, plus a half of vector Y. So I now have that vector AN plus a half of vector Y.
Please rejoin.
I'm now asked to show that MN is parallel to AB.